Okay, welcome to our power transmission class, Chapter 8 review. Now, Chapter 8 is, in some cases, kind of like a kind of a review of previous work in some of the other chapters and also in some of the labs. However, it jumps into our final lab, which is basically shaft alignment. And in this chapter, there's some key terms that I want you guys to learn, some very, very important terms. Also, I'm going to kind of soft shoe around some of the things, some of the math that Chapter 8 gets into, because I don't think it's important. I think that some of the math they use for shaft alignment, it's unlikely that you'll need to do that in your actual job. And if you do have to do that, they will give you specific procedures and or some training for it. So what I'm really wanting for you guys to get out of this class is learn some key terminology, and I want you to learn a basic concepts of how you do these shaft alignments. And the great thing about doing the shaft alignment now is you've already done it once. You've already done it when you set up your V-belts, and again for the chain. So and you should have done it twice. So so getting into the science of it, getting into how it really works now, since you've physically done it, will give you a little bit better insight. So let's talk about shaft alignment. In page 168, section 8-1, it takes you through how you line up pretty much a pulley. This is straight out of our lab, and I'm sure you guys have all run into these pulley misalignments and have had to adjust them manually, painfully in some cases, to get a perfect alignment between your pulleys. So now we're going to learn about the different specific terms you need to remember when it comes to misalignment. So why is it important to remember the terms? Because it lets you communicate with your bosses, with other maintenance technicians accurately. So rather than waving your hands around and holding up your fingers to describe how the alignment is working or not working, you can give them this specific kind of alignment or misalignment that you're running into, and they can support you in that process. And obviously, you'll get more credibility if you really know what you're talking about here. So the book talks about three basic misalignments between pulleys. We've got offset, parallel, and angular. And they show you a lovely illustration of that on page 168. So your perfect pulley alignment is here. That one probably doesn't need any explanation. Offset means that one pulley is slightly offset from the other, but they're basically aligned otherwise. You also have non-parallel misalignment, which means that one pulley is tilted away from the other pulley. And then you've got your angular misalignments, which basically means your belt has started to twist. You have sort of a taco effect going on, and that the angles of the shafts they're no longer parallel to each other. So these are very important key terms. So you have to remember the offset, parallel, and angular misalignments. The book takes you through the procedure that we went through very briefly in the lab. The book takes you through a much more kind of rigorous procedure in doing that measurement and describes those 4 points, A, B, C, and D, that we very briefly went through in the lab. So you wanted the outside and inside points on your pulleys to be able to line up right up against the straight edge, and we actually did that as part of the labs. So it's worth reading through this, but I want to mention one key thing. The book says, in terms of offset alignment, it's usually acceptable to have no more than 1/10 of an inch error per foot of span, which is a very specific number. I'm not sure where they got that number. In my experience, a lot of people eyeball these V-belts, but I'm sure there's an engineering book somewhere where they came up with that 1/10 of an inch in error per foot of span. So our span was roughly 1.5 feet. So our error could have been as much as 1/10 plus 1/20 of an inch, which is probably around 1/8 of an inch would be my guess. And so as long as we got within an eighth of an inch in terms of alignment, as measured from your worst error with the straight edge, then you're probably going to run that belt okay. So it's a very important number to remember. So I want to mention, as they go through how all of these alignments can be fixed, I want to mention one key fact here right at the end of these pulley misalignments. And that is all 3 misalignments must be corrected. And if you've got a lot of misalignments between your pulleys, you got to correct them one at a time. And then check each one over again once you've corrected it. So basically, you can't just try to fix them all at once. Try to fix each misalignment one at a time. So that's an important procedural approach. Now in page 170, we jump right into probably the most important part about this chapter, which is coupling. What is a coupling? A coupling is the link between a motor and a gearbox, or a motor and a pump. It's basically where you want to have one shaft which is providing energy, send that energy to another shaft which is going to use that energy. So it's often a connection between a motor and a pump and a motor and a gearbox. And we're pretty much going to be just using 2 shafts during our couplings, but we're going to be simulating a potential motor and a pump scenario. And some of the early discussions we get into, and I didn't highlight this, is the concept of soft foot. I've given you guys a video to watch on all the pre-alignment steps. There's 4 key pre-alignment steps you need to go through before you can do your alignment between 2 shafts properly to make this coupling work right. And one of those key steps is, well, actually 2 of them are related to soft foot. Soft foot means that your motor is not mounted properly. It means that something isn't right with how that motor is mounted. It doesn't necessarily mean you've got like a soft mount, like a squishy mount. It could mean a number of different things, but it basically means that no matter what you do with that coupling, it won't necessarily stay in alignment properly. So first you have to fix your mounting on your motor to get it to work properly. And so there's some key terms for describing soft foot. For instance, parallel soft foot means that the motor plate is not in parallel with whatever you're driving, say the pump or the gearbox plate. They're just not in parallel with each other. So you need to raise up the motor or reduce the height of the motor somehow to get it to align properly and make the 2 mounting plates parallel. Angular soft foot means where something is bent. One corner is bent so that there's no way you can mount the motor and have it end up in parallel between the motor and whatever you're driving, like the pump. And this is usually a case where they say of a bent foot on the motor. Somebody dropped it before it got mounted, somebody banged into it, or just maybe you've got rust or some other problem occurring. And so that can be fixed by re-welding or shimming up and that sort of thing. The next one is called a springing soft foot. This is a case where the motor, when you bolt it down, it actually flexes the plate or the motor mount, and when you release it, it springs back. And it could be occurring from a variety of ways: dirt, debris, once again, a bent or broken plate. And then you've got a third category called induced soft foot. This is a variety of reasons why you might get it, and a lot of them have to do with the dynamic environment that you're mounting your motor in. You could have a lot of vibration occurring in that environment, so that as your motor vibrates, it goes in and out of alignment. So that's induced softwidth. So everything looks great until you fire up the motor, and then you get a problem with alignment. So you really have to go through a lot of steps to make sure your motor is mounted and set up properly before you get into your whole alignment procedure. Okay. Once again, we're showing the figures of how the different alignments look in the shaft alignment model. So now we're talking about transmitting power from one side of this coupling to the other. This book only shows one kind of coupling. There are dozens of different kinds of coupling, and in our lab we are going to be using at least 4 of them. We're going to be using 4 different couplings, and you're going to learn some basics about those 4 couplings. But this is what those different types of alignment look like. Now, many couplings between motors and pumps look like this. And it's basically a flange. This is on one side and almost identical on the other. And then you've got some sort of rubber compression kind of a flange, some sort of rubber compression power transmission device that gets pressed between those flanges. And in order to make sure your shafts are in alignment, you can measure on several of these things in that coupling flange. And it's going to make more sense when we get into the lab and we actually look at 1 or 2 of these. But you should know that the face of the flange is the part facing outward towards the other matching flange on the other shaft. The rim is the outer rim, that's kind of obvious, and the hub is the part where you've got your set screw, and that gets screwed down to the shaft. They go through a procedure for mounting these flanges, and this is a very, very useful procedure. I expect you guys to follow this procedure when we get into the lab, right? And one of the first steps is once you got your gearbox and motor, or your motor and pump in some cases, you want to make sure that the coupling flanges are on the shafts before you tighten them down. Why? Because a lot of times you won't be able to fit this flange onto the shaft between the 2 different shafts when it's all tightened down. So what we want to do is slide this onto the shaft, slide it out of the way, back up against the motor or back up against the gearbox, and then bolt down your motor and gearbox. So we're going to be following that procedure in the class and in the lab. So this is an excellent procedure. Read through it. If you have questions, then we'll definitely get them answered in the lab. The book talks a lot about motors and pumps, and I have to admit that mostly what you're going to run into in motors and pumps, or motors and gearboxes, is very big, heavy-duty devices. The pumps I've used run anywhere between, say, 1 horsepower up to 100 horsepower pumps, and they are so big you can't lift them individually. You need like a fork truck or a crane to move them. And they're very, very tough to move around. And so a lot of times they're mounted with these jack screws, these screws that you can tighten or loosen to move them around to give you a precise alignment. And here on this figure 8-10, it shows you a typical jack screw arrangement where you're on your motor. You've got 4 screws that you can use to push this motor back and forth or rotate it. By tightening these screws and loosening those screws, you push the whole thing down, and vice versa. But in many cases, you don't get jack screws, which is why I have highlighted this little thing. If there are no jack screws to aid in the movement of the machine, which is true for many, many smaller horsepower devices, but are still very, very heavy, then you want to gently pry against the machine so as to cause it very small controlled movement. So gently pry against means use a big screwdriver or a small pry bar to gently nudge it. A lot of guys will show up with a hammer and bang against it. And this might be okay for something like 20 years ago or even 100 years ago. But nowadays, if you have any kind of electronic device attached to that motor or that pump, and a lot of them now have electronic devices to measure vibration, then you're going to break it. If you've got your laser alignment or your dial indicators attached to that device and you bang it with a hammer, you may break those electronic devices. So this is my highlighting of this as a strong warning to you. So this is sort of how you do all your pre-alignment steps. This book is providing you some good ideas for that, but the video is better. There's a video talking about the 4 steps of pre-alignment. It does a very, very good job of taking you through all those steps.